Imagine stepping onto a small airport tarmac and seeing a plane that costs less than $84,000. Yes, less than a brand new Tesla Model S. Elon Musk has just unveiled the Tesla super electric plane. And this isn't just a toy or a prototype, it's a plane that could reshape short-range aviation forever. Important point. But here's the question. How can a plane this cheap actually fly safely? And could it really threaten Boeing's entire business? 15 years ago, people laughed when Tesla launched electric cars. Critics called the idea impossible. Fast forward to today, and electric cars dominate the roads. Now, Musk is bringing the same revolution to the skies. And this time, it's not just about the vehicle, it's about price. Technology, infrastructure, and software all working together to create a new aviation ecosystem. You might be thinking, $83,595? That's way too cheap for a plane. But when we break it down, the numbers tell a different story. This plane is cheaper to operate, faster to turn around, and smarter than almost anything currently available for individuals or small businesses. And the kicker? With the Tesla super electric plane, Boeing's traditional dominance in short-range flights could face a serious challenge. Before we take off, I have a small request. If you love clear, practical tech insights with real-world value, hit the notification bell and join our community. Important point. Could owning a plane for less than $84,000 finally make flying as common as owning a car? Let's see how. Price shock and accessibility. To understand why this plane is revolutionary, we need to compare it with traditional small aircraft. Tesla super electric plane, $83,895 Cessna, $172, $400,000. $600,000. Piper Archer, TX, $400,000, $520,000. Cirrus SR22, $1,000, that's right. Tesla is offering a plane for roughly 1/5 to 1/10 of the cost of a conventional small aircraft. Suddenly, flying is no longer just for wealthy pilots or flight schools with deep pockets. Important point. Imagine flying to a nearby city for the same cost as filling up your car. Sounds impossible? Let's dive in. Picture this. A small town in the Midwest with a population of 20,000. With a Tesla plane priced at $83K, the local flight school can finally afford to expand its fleet. Residents could take a commuter flight to the nearest city instead of driving 2 or 3 hours. Local businesses could deliver light cargo between towns efficiently. Even hobbyists could consider owning a plane for weekend trips, something that was almost impossible just a few years ago. The infrastructure is already there. The United States has about 5,100 public-use airports out of nearly 9,500 total. With Tesla's low entry price, small operators could feasibly own one or several aircraft to meet local demand without relying on major hubs or expensive facilities. Important point. Tesla isn't just selling planes, they're unlocking an entirely new market for short-range aviation. Are you ready for it? Cost per flight hour. The real game changer. Price grabs attention, but the real factor that decides success is cost per flight hour. How does the Tesla super electric plane achieve this? Fewer moving parts. The electric motor has very few components, doesn't require oil changes, and avoids a complicated fuel system. Lifetime maintenance costs could be half those of conventional piston planes. Electric car experience shows us this is realistic. Lower energy costs. A full charge for a Tesla plane using commercial electricity at roughly 0.12, 0.13 per kilowatt Costs only about $262.90. Compare that to a training Cessna 172, which burns 9-10 gallons per hour at $6 per gallon. Fuel alone runs $55-65 per hour, not counting oil, spark plugs, and overhauls. Important point. What if flying short distances could cost less than driving your car? Tesla is making this real. The result is dramatic cost savings. Short routes that were previously uneconomical suddenly make sense. Operators can price flights affordably, run more daily cycles, and create steady revenue streams. Intertown travel, commuter hops, and light cargo flights within a few hundred miles suddenly become viable. Imagine a fleet of Tesla planes running short routes between towns, each plane flying multiple cycles per day. Daily utilization goes up, costs per seat drop, and operators have a flexible, profitable business model. Boeing doesn't operate in this segment, but the ripple effect could affect their aftermarket services, as small flights shift from piston aircraft to electric alternatives. Air supercharger network and modular batteries. Even with low costs, the biggest challenge for electric aviation is charging. Tesla solves this with the air supercharger network. Instead of treating an airport as just a refueling stop, Tesla turns it into a smart charging node. Each station combines high-power DC connectors, megawatt class, on-site energy storage to stabilize power during peak times grid, or solar input during off-peak periods. Charging 300-400 kilowatt-a-watt takes roughly 20 to 30 minutes, plus 5-10 minutes for docking, chalking, and inspection. But Tesla doesn't stop there. They also implement modular battery packs. Ground crews can swap a depleted pack with a fully charged one in minutes, keeping planes in the air without downtime. Important point. Could you swap a plane battery faster than refueling a car? Tesla's system makes this possible. Software tracks state of charge, temperature, and cycle life, deciding when to charge, swap, or prioritize power across multiple aircraft. The result: a fast, reliable, and scalable network that allows operators to maintain high daily cycles and low costs per flight. This system is what makes short hops faster than driving in some scenarios. Imagine leaving your hometown airport, swapping a battery in minutes, and reaching the next town efficiently, something no conventional piston aircraft can compete with. Scalable production and modular design. Tesla isn't just innovating in flying, they're applying automotive-scale manufacturing. Fewer parts, standardized modules and large casting speed assembly, modular fuselage sections, landing gear, cabin modules, and wiring looms reduce inspection and installation time. FAA performance-based certification allows modern, efficient production processes. Important point. Could Tesla build planes faster than traditional small aircraft makers? The answer is yes. This means Tesla can ramp production faster than traditional small aircraft manufacturers, meeting demand while keeping costs low. By applying automotive assembly techniques to aviation, they can deliver planes more quickly and with fewer quality variations, putting pressure on competitors to keep up. Software and safety. Tesla's software is the secret weapon. The plane integrates multiband GNSS navigation, aviation-grade MU radar altimeters, temperature and pressure sensors, forward and downward-facing cameras, ADS-B traffic monitoring, digital terrain maps, and weather data. This feeds into a flight computer with redundant processors, delivering real-time guidance, automatic pre-flight checks, battery monitoring, and predictive maintenance. Protective layers keep the plane within safe flight limits, alerting the pilot or gently correcting deviations. Important point. Could a beginner safely fly a plane like a pro? Tesla's AI co-pilot makes this possible. The result? Safe, simple flying, even for beginners. Short hops feel almost as effortless as driving a Tesla EV. Market impact in Boeing. Boeing's portfolio focuses on large jets and cargo aircraft. Tesla's super-electric plane operates in a completely different segment, targeting short-range routes and local air taxis. However, the ripple effect could affect Boeing indirectly. Short-haul missions migrate from piston planes to electric alternatives. Maintenance, fuel, and service revenue for traditional aircraft could decline. Public expectations for affordability and speed of delivery could pressure competitors to innovate faster. Important point. Could a $84,000 electric plane really disrupt Boeing's empire? The answer might shock you. Tesla isn't just building planes. They're reshaping the economics of short-range aviation. Finally, in summary, the Tesla super-electric plane offers jaw-dropping affordability, low cost per flight hour, high utilization through air superchargers and modular batteries, a smart, safe software co-pilot. Important point. If this plane landed in your town tomorrow, where would you fly first? The future of aviation is here. Don't miss out. So here's a question for you. If a Tesla plane landed in your town tomorrow, where would you fly first? Comment below. Don't forget to subscribe to Road Zone Reviews and hit the bell. Next, we'll explore timelines, risks, and how soon you could actually own one.